Quadratic equations. In our previous classes, we have understood how to frame equations out of given mathematical situations, and we have reached to the solutions using the variables we have used to discuss any mathematical situation. We mostly dealt with linear equations having either one or two variables of degree 1, and when it comes to choose variables either 1 or 2 of degree 1, for example x and y, then it is a good idea to represent the solution graphically in a coordinate plane, that is in a xy plane, or in a 2D plane, two-dimensional plane. For example, if I simply say that x equal to 4, then I mean something graphically, and if I simply ask you to represent it, then the representation should mean something and can be understood by anyone. X equal to 4 will represent a straight line in xy plane where the value of y will change but value of x is always 4. It will represent a vertical line. So here we saw that there is a relation between the x value and the y value. X is constant here. Now imagine both x and y changes while following certain mathematical rule. For example, if I say that 2x plus 3y equal to 9, what I have done is I just created a mathematical statement which has equal to symbol, this symbol, and this is the reason it has mathematical meaning. First meaning is that for every value of x, there exists a value of y which satisfies the above equation or mathematical statement, this statement. If you plot all the values of corresponding x and y in a xy plane, you will see that it represents a straight line, and this is why we call it a linear equation in two variables. So this is a linear equation in two variables. And if someone asks you how many solutions does the above equation has, then you will say that it has infinite solutions, as there are infinite values of x with respect to y which satisfies the above equation. So there are infinite x and infinite y. And in simple terms, you can say that a line in a xy plane can be extended to both the directions infinitely. What if there are two linear equations in two variables and someone asks you what is the common solution of both the equations? Then you will simply say that because two lines, the two equations here, for example, this white line is one equation, this yellow line is another equation. These two lines are linear equation in two variables. So because the two lines, these two equations here can intersect at most one point, so there will be only one and only one solution which satisfies both the linear equations, and we call it solving both the two equations simultaneously. For example, in this case, we have two equations, that we mean two lines, and at most these two lines can intersect at only one point, and this one point is common to both the lines because this common point is lying on both the lines. So this is the solution, this is the common solution for both the lines. So we have a value of x and we have a value of y which satisfies both the equations, which satisfies both the lines. So here the solution was that point of intersection of both the lines, because that is the only point which lies on both the lines, except on situations when the lines coincide with each other or are parallel to each other. Think why. And in your higher classes you will come across equations having higher power of variables x and y. For example, the standard form of a circle is x square plus y square equal to r square. This equation will always represent a circle having its center at the origin of the coordinate axis and radius equal to r. Here you saw that both the variables x and y has degree 2. However, equations with degree 2 and having only one variable will represent a parabola. For example, y equal to ax square plus bx plus c. This polynomial represents a parabola in xy plane and we call it a polynomial equation. For example, here this parabola is a equation. This is the general form. The general form of this parabola is ax square plus bx plus c. So the mathematical expression ax square plus bx plus c is called the quadratic polynomial in one variable. We put equal to y to understand the relation between x and y. For example, here we have considered this polynomial equal to y. So we put equal to y to understand the relation between x and y, considering y any constant value. Let's say this constant value of y is 0. So I will say that ax square plus bx plus c is equal to 0. I have considered y as 0 and we call it general form of the quadratic equation. Notice that we have considered y as 0 here and we know y equal to 0 represents x-axis. For example, in a coordinate plane, in a xy plane, a parabola will look like this curve, this yellow curve, and this O is the origin of this coordinate axis, and this is the equation of the parabola. This is the polynomial. This curve is the polynomial y equal to ax square plus bx plus c, and this x-axis is the equation y equal to 0. Y equal to 0 is the equation of x-axis. So for this parabola, the solution is the 2 point of intersection. So let's say this point, because this is x-axis, so the y value is 0, and let's say the x value is alpha, and for this point the coordinates are beta and 0, beta comma 0. So this is x value, this is y value, this is x value, this is y value. So there are two x values and two y values, both the y are 0. So the solution of this quadratic equation ax square plus bx plus c equal to 0 will be the point of intersection of the parabola y equal to ax square plus bx plus c and the line y equal to 0, that is x-axis. In case when the parabola does not intersect the x-axis, then we say that this quadratic equation has no solution. For example, in this diagram, this parabola is not intersecting the x-axis, so this equation has no solution. This quadratic polynomial has no solution. Equation has no solution. Understanding both the algebra and geometry of quadratic equation continues in higher classes and is very important. Study of quadratic equations clears your concepts about theory of equations. After studying quadratic equations, you will realize the importance of finding geometry in algebra and finding algebra in geometry. History of quadratic equations. Babylonians were the first to solve the quadratic equations of the form x square minus px plus q equal to 0, where p and q belongs to any real number. Brahmagupta AD 598 to 665, an Indian mathematician, gave an explicit formula to solve a quadratic equation of the form ax square minus bx equal to c, where a, b, c belongs to R and a is not equal to 0. An Arab mathematician, Al-Khwarizmi, in AD 800 also studied quadratic equations of various types. An ancient Indian mathematician, Sridharacharya, derived the well-known quadratic formula for solving a quadratic equations of the form ax square plus bx plus c equal to 0 by the method of completing the square. This is being used as the standard formula to solve any quadratic equation in one variable. According to the formula, the roots of the quadratic equations ax square plus bx plus c are given by, there will be two roots. The one root will be alpha, we call it x1. One value of x will be x1, we call it alpha, which is equal to minus b plus square root of b square minus 4ac by 2a, and another root will be x2. We represent it by a beta, and which is equal to minus b minus square root of b square minus 4ac by 2a. So which means by simply looking at the equation we can directly, because we know the equation, we know a b c belongs to R, belongs to real number, so we will be able to find the two roots, which is x1 and x2, or which is alpha or beta. This formula is called Sridharacharya's rule, where b square minus 4ac is equal to d is called the discriminant of the equation. For example, this is the coordinate axis, and this is the parabola. These are the two points, or we can say these are the two roots. One root is x1, which is alpha, another root is x2, which is beta. This is the parabola y equal to x square plus bx plus c. So this is how it is represented geometrically. Now let us come to definition of quadratic equation. In algebra, a quadratic equation is a polynomial equation with one or more than one variable in which the highest degree term is of second degree. For example, a univariate single variable quadratic equation has the general form as ax square plus bx plus c equal to 0, where a is not equal to 0 and a, b, c belongs to R, any constant number, and x is the variable. A is called the coefficient of x square, this A. B is the coefficient of x, this B. C is the constant term, C is the constant term. Now definition of the quadratic equation. So here the graph of a univariate quadratic function is a parabola whose axis of symmetry is parallel to y-axis as shown at the right. Look at this diagram very carefully. Here these red lines are the coordinate axes, and this yellow curve is a parabola which is a univariate quadratic function, y equal to x square plus bx plus c. So this parabola has a axis of symmetry. This dotted line is the axis of symmetry, which means the parabola from this point to this point is symmetric from this point to this point. So this is why this is the axis of symmetry, and these are the two point of intersection of this parabola and the line y equal to 0, which is x-axis. So we call the coordinates of this point, let's say these are alpha comma 0, and coordinates of this point are beta comma 0. And later you will realize that the coordinates of this point is minus b by 2a comma minus d by 4a. We will see how these coordinates are minus b by 2a and minus d by 4a. So the solution to the univariate equation are called roots of univariate function. Here we say that y is function of x, that is y is function of x and is represented as fx equal to ax square plus bx plus c. The bivariate case in terms of variables x and y has the form fx comma y equal to ax square plus by square plus cxy plus dx plus ey plus f, with at least one of a, b, c not equal to 0, with at least a, b, c not equal to 0, where a, b, c, d, e, f belongs to R, belongs to real number. Setting this function equal to 0 gives rise to a conic section, a circle or other ellipse, a parabola or a hyperbola. A quadratic function in three variables x, y and z contains exclusively terms x square, y square, z square, xy, xz, yz, x, y, z and a constant. So we can say that the general form of a quadratic function in three variable will look like this. We will represent it as function of x, y, z equal to ax square plus by square plus cz square plus dxy plus exz plus fyz plus gx plus hy plus iz plus j. So where a, b, c, d, e, f, g, h, I, j are numbers, are belongs to R, with at least one of the coefficients a, b, c, d, e, f of the second degree term being non-zero. Now let us come to solutions or roots or zeros of a quadratic equation. I am sorry. The values of x for which the equation of the form ax square plus bx plus c equal to 0 is satisfied are called the roots or solutions or zeros of the quadratic equation. A quadratic equation can have at most two zeros. The two roots of the quadratic equation are given by x1 equal to alpha equal to minus b plus root d by 2a and x2 equal to beta equal to minus b minus root d by 2a. So this is the representation of the roots. We call the one root as, we consider this as x1 and the other root as x2, or we call this x1 as alpha and this x2 as beta. So these are the two roots, and we know d is equal to b square minus 4ac and is called discriminant of the quadratic equation. So depending on this value of d, we can say that whether a quadratic equation has a real solution or imaginary solution. If we put these two values of alpha and beta one by one, then the equation will be satisfied. If this is the equation, and we know alpha and beta are the roots of this equation, so in place of x we will put alpha, so the equation will become a alpha square plus b alpha plus c, and after calculation it will become equal to 0. Similarly, a beta square plus b beta plus c equal to 0. Finding the solutions or roots of the quadratic equation. First method is factorization method, which is the method of splitting the middle term. Let the given quadratic equation be ax square plus bx plus c equal to 0. So let ax square plus bx plus c is a factor of two linear polynomials. So let's say the two linear polynomials are px plus q and rx plus s. Here we have considered that we are able to factorize this polynomial into two real linear polynomial factors. So you will come across many polynomials where you won't be able to factorize in such a way. So so let us multiply these two brackets. So we will get prx square plus psx plus qrx plus qs equal to prx square plus ps plus qr. In the ps plus qr is common, and x plus qs. So if we we can say that this equation, this polynomial is equal to this polynomial. So we can compare the coefficients. For example, the coefficient of x square is a. Here the coefficient of x square is pr. So I can say that this a is equal to pr, and this b is equal to ps plus qr, and this c equal to qs. So this is a, this is c, and this ps plus qr is b, and these are the two parts of b, b1 and b2. So this b is divided into two parts. This is b1 and this is b2, and c is qs. This c is qs. So we see there is a relation. If I multiply a and c, which means pr and qs, so the multiplication is pr qs, and if we multiply b1 and b2, we get ps qr, or in other words pr qs. So multiplication of a and c is equal to b1 into b2. So by comparing the coefficients, a equal to pr, b equal to PS plus QR, where this is B1 and this is B2, and C equal to QS. Therefore A into C is equal to B1 into B2. So A into C will be equal to B1 into B2. So while factorizing quadratic polynomials, the middle term, that is B, is divided into two parts, B1 and B2, such that A into C equal to B1 into B2. A into C equal to B1 into B2. Factorization method, splitting the middle term, finding the solution or roots of the quadratic equation. Consider the equation x square minus 5x plus 6 equal to 0. So here I see that a is 1 here. The coefficient of x square is 1. So a is 1. B is equal to minus 5. The coefficient of x is minus 5. C is equal to 6. The constant term is 6. So we need to divide this minus 5 into two parts such that the product of those two parts is equal to 6, positive 6 plus 6. So we can divide we can divide it in minus 2 and minus 3, because the sum of minus 2 and minus 3 is minus 5 and their product is equal to plus 6. So here B1 and B2 is minus 2 and minus 3, such that B1 into B2 equal to A into C. So therefore x square minus 5x plus 6 equal to 0 is equal to x square. This minus 5x is divided into two parts, minus 2x minus 3x plus 6. Now by factorization we have taken x as common, x minus 2, then minus 3 is common in these two terms, and we get x minus 2 equal to 0. So the two linear factors are x minus 2 and x minus 3 equal to 0. So we say that either x minus 2 equal to 0 or x minus 3 equal to 0, then only the product will be equal to 0. So the answer is x equal to 2 or x equal to 3. So we can say that for this quadratic equation, the two values of x which satisfies this quadratic equation are x equal to 2 and x equal to or x equal to 3. If you put x equal to 2 or x equal to 3, you will get 0 equal to 0. So for these two values the equation gets satisfied, and we call it the roots or the solutions of this quadratic equation. We have done this by using the method of splitting the middle term. This is the method of factorization. Now let us come to relation between the roots and coefficient of a quadratic equation. Another way of thinking the solution: let the given quadratic equation be ax square plus bx plus c equal to 0. We know this is the general form of the quadratic equation. Let the two roots of the equation are alpha and beta. So therefore ax square plus bx plus c is equal to if because we know the two factors are two roots are alpha and beta, so we can represent this polynomial as a into x minus alpha into x minus beta, because when you will equate this equal to 0, you will get x equal to alpha or x equal to beta. So here we have taken a as common, so in the bracket we are left with x square plus b by ax plus c, and it is actually c by a is equal to a x square minus beta x minus alpha x plus alpha beta, and by calculation this a and this a will get cancelled out. So we are left with x square plus b by ax plus c by a. This is c by a equal to x square minus, if you take x as minus x as common, you are left with alpha plus beta. So minus alpha plus beta x plus alpha beta. So it means it implies that x square plus b by ax plus c by a equal to x square minus Let alpha plus beta is the sum of the roots. So we represent this sum as S, capital S. So alpha plus beta is capital S. X is there, plus this alpha beta is the product of the roots, alpha into beta. There are two roots, alpha and beta, and alpha beta is the product of the roots, and we have represented by capital P. So from by comparing the coefficients of left hand side and right hand side, I can say that the sum of the roots, which is represented as S, is equal to alpha plus beta, and this alpha plus beta is equal to minus b by a, negative of b by a. Alpha plus beta equal to minus b by a. Similarly, the product of the root is alpha beta. So by comparing the coefficients, this alpha beta will be equal to c by a, which means product equal to c by a. So we can say that sum of the roots alpha plus beta for any quadratic equation is minus b by a, and product of the roots for any quadratic equation is always c by a. So this is the relation between the coefficients and the roots of the quadratic equation. Now let us try to understand completing the square method, Sridharacharya's rule. Consider the quadratic equation ax square plus bx plus c equal to 0, where a, b, c are real and a is not equal to 0. Ax square plus bx plus c equal to 0, which means x square plus b by ax plus c by a equal to 0, dividing throughout by a. So here you need to consider a very basic formula, that a plus b whole square is equal to a square plus 2ab plus b square. So, or in other words, I can say if I have two values a and b such that a square plus twice of a into b plus b square, then I can say it is equal to a plus b whole square. So by remembering this concept, we have divided this equation throughout by a. So we are left with x square plus b by ax plus c by a equal to 0. Now this x, let's say this x is the first object, x square plus I need 2ab. So I know one object is x and another object is b by a, so that I will get b by ax, but I need 2ab. So I will multiply the expression by 2 and divide the expression by 2. So I will have 2ab, this 2x b by 2a plus b by 2a whole square, minus, and I will subtract b by 2a whole square in order to make the balance, plus c by a equal to 0. So this expression, because see, this is the splitting the middle term, you can say. We have converted it, the polynomial, into two parts, one as a perfect square. This is the square, perfect square, x plus b by 2a whole square, a square plus 2ab plus b square, minus and equal to b by 2a square minus c by a by transposition. So we get the solution by solving it further. X plus b by 2a whole square equal to b square minus 4ac by 4a square. So we can say x plus b by 2a equal to square root of b square minus 4ac by 2a, which plus minus square root of b square minus 4ac by 2a. And by transposition I can say x equal to minus b by 2a plus minus square root of b square minus 4ac by 2a. So x is equal to minus b plus minus root d by 2a, where d equal to b square minus 4ac and is called the discriminant of the quadratic equation. So this is the quadratic formula. So the two roots are x1 equal to alpha equal to minus b plus root d by 2a, and x2 equal to beta equal to minus b minus root d by 2a. Now let us understand nature of the roots. Any quadratic equation can have maximum of two roots, and depending on the value of d, the nature of the roots are decided as understood by simply looking at the quadratic formula. Three cases arises. For example, when d, which is b square minus 4ac, is smaller than 0. So we know the quadratic formula is x equal to minus b plus minus root d by 2a. This is the quadratic formula. These are two values of x. One is with plus and another one is with minus. So if this d is smaller than 0, then square root of a negative number is an imaginary number, so is a complex number. So we will say that the roots are not real, that is they are imaginary. And this type of curve, this type of curve where the discriminant, which is b square minus 4ac, is smaller than 0, will never cut the x-axis. On whatever quadrant the curve belongs to, it will never cut the x-axis. So there will be no solution. However, in case when d is equal to 0, we know the quadratic formula is x equal to minus b plus minus root d by 2a. So these are the two values of x. So the roots are rational and equal because d is equal to 0. So this term will become 0. So we are only left with minus b by 2a. So both the roots alpha and beta are minus b by 2a. Similarly, when d is greater than equal to 0, so when d is greater than equal to 0, two possibilities are there. When d is a perfect square, if d is a perfect square, then roots are rational and unequal. For example, look at this diagram. Here this parabola has two roots, this point and this point. These are rational and unequal. And when d is not a perfect square, then roots are irrational and are unequal. Still roots are irrational but are unequal. Now finding the roots of a quadratic equation by a graphical method. Method 1. In this method we consider the entire polynomial as one curve and we find where the curve cuts the x-axis, that is the line y equal to 0. Let y equal to x square minus 5x plus 6 is the quadratic polynomial. Preparing the following table by assuming different values of x. So we here y is function of x. So for different values of x we will get different values of y. So let's see what we get. We will plot a table and we will put different values of x. For if x is 0, y is equal to 6. If x is 1, y equal to 2. If x is 2, y equal to 0. Similarly we get these points, these x and y points. So these are the coordinates in the xy plane. So finding the roots of this is the graphical method. So let's plot the points 0 comma 6, 1 comma 2, 2 comma 0, 3 comma 0, minus 1 comma 12, minus 12, minus 1 comma 12, minus 2 comma 20, minus 4 comma 2, 5 comma 6. So let's plot these points. Let's say these are the coordinate axis and these are the points. This is the origin O. This is 2, 4, 6, 8, 10, 12. These are the positive values and these are the negative values. These are four quadrants. So we have plotted these points 0 comma 6. So 0 comma 6 is this point. So I have labeled this point as like this. Similarly 1 comma 2. So 1 is the midpoint of 0 and 2. So 1 comma 2 is this point. I have labeled this point. 2 comma 0. So this is 2 comma 0, this point. 3 comma 0. This is 3 comma 0. Minus 1 comma 12. Minus 1 will be this point. Minus 1 will be this point. Comma 12. So this point is minus 1 comma 12. Minus 2 comma 20. Similarly we will plot all the other points. Minus 2 comma 20, minus 2 comma 20, this is the point. 4 comma 2, this is 4 comma 2. 5 comma 6, this is 5 comma this is 6. So if we join all these points, we will get a parabola. This is the equation of this parabola is y equal to x square minus 5x plus 6, and we are required here to find the solutions graphically. I can see that this parabola is intersecting the line y equal to 0, which means the x-axis, at 2 points, at x equal to 2 comma 0, this point, and at x equal to 3 comma 0, 3 comma 0, this is this point, this point. So this is 2 comma 0, this is 3 comma 0, and so here we notice that the given graph, the parabola, intersects the x-axis at 2 comma 0 and 3 comma 0. So this is the solution of this parabola. So the roots of the given quadratic equation here are x equal to 2 and x equal to 3. Now finding the roots of a quadratic equation by graphical method, method 2. So this is another way of finding the graphical method of the quadratic equation, and here we consider the same given equation in two parts. Let the general form of the quadratic equation is ax square plus bx plus c equal to 0. So this is the general form of the quadratic equation. So by transposition, ax square is equal to minus bx minus c. Transfer this bx to right hand side and you will get minus bx, and this minus c to right hand side, minus c. You know, this is a univariate quadratic function, so this will represent a parabola, and this is a linear equation in one variable, so this will represent a straight line. So the point of intersection is the solution. The point of intersection of this polynomial equation and point of intersection of this polynomial equation, which is a straight line, will be the solution. So now draw the graph of y equal to ax square and y equal to minus bx minus c. For example, solve 2x square minus x minus 3 equal to 0 graphically. If I ask you to solve this quadratic equation, which is 2x square minus x minus 3 equal to 0 graphically, in this second method, so we will keep 2x square here, and by transposition, this will be equal to x plus 3, adding x plus 3 to both sides. So we will get 2x square equal to x plus 3. So let the two graphs are y equal to 2x square, y equal to 2x square, and y equal to x plus 3, y equal to x plus 3. So let these two equations are a and b. So let's plot y equal to 2x square. We know this will represent a parabola, y equal to 2x square, and this parabola will always pass through the origin. Think why. So for this polynomial equation, we have corresponding x and y, 0 0 1 2 2 8 minus 1 2 minus 2 8. For 0, 2 into 0 square is 0. For 1, 2 into 1 square is 2. So similarly we get these points. So we have plotted these points here, and similarly we have plotted the points for y equal to x plus 3. So this green linear equation y equal to x plus 3 is a straight line, and this is the curve y equal to 2x square, and their point of intersection is the solution, the x coordinate. So I see that this point is the point of intersection whose coordinates are minus 1 comma 2. So minus 1 comma 2, this point is common in both this y equal to 2x square and the line y equal to x plus 3. And the another point of intersection is this point, and when you put x equal to 1.5, you get y 4.5 in both the cases, for y equal to 2x square and for y equal to x plus 3. So this is the solution. So clearly the x coordinates of the point of intersection of the two polynomials is the solution. Therefore the roots are x equal to minus 1 or x equal to 1.5. Geometry of the univariate quadratic function. Regardless of the format of the graph of a univariate quadratic function, fx equal to ax square plus bx plus c is a parabola. So there will be three types of graphs you will come across. For example, for d greater than 0, if d is greater than 0, obviously the graph will intersect, the parabola will intersect the x-axis at two different points, and we say that the roots are different. So there are two roots, and if in the polynomial a is greater than 0, then the curve will open upward. If a is smaller than 0, then the curve will open downward. So and for d equal to 0, the parabola will cut the x-axis at one point. So both x and y, both alpha and beta are equal, both the roots are equal. And when for d smaller than 0, the curve will not cut the x-axis. Maximum and minimum value of a quadratic expression. Consider the quadratic expression y equal to ax square plus bx plus c, where a is not equal to 0 and abc belongs to real number. So y equal to ax square plus bx plus c. So y equal to a, we have taken a as common. Now in the bracket we have x square plus b by ax plus c by a. Y equal to a common. We are completing the square. We have considered this as first element and b by a as second element. So x square plus 2x b by 2a plus b square by 4a square, because this is b, so a square plus 2ab plus b square means b by 2a square, so b square by 4a square, and we have plus c by a, we put this plus c by a, and this b square by 4a square is the extra term. So in order to make the balance, we have added minus b square by 4a square. So this is in the bracket, big bracket. So y equal to a common, and these first three terms, a square plus 2ab plus b square is x plus b by 2a whole square plus, and by solution you will get this expression 4ac minus b square by 4a square. uh, but you know that b square minus 4ac is d. So so I can say that 4ac minus b square is minus d. So it implies that y equal to a x plus b by 2a whole square plus minus d by 4a. This is minus d by 4a. Let us say this is expression a. So this expression a has two parts. Expression 1, which contains the term x and then x plus b by 2a square, and expression 2, which contains the term minus d by 4a. Now if a is greater than 0, then for any value of x, this expression will always be positive, and the minimum value is 0 at x equal to minus b by 2a. For example, I am talking about this expression only, this expression 1. If a is greater than 0, then for any value of x, either x is positive, negative or 0, anything, for any value of x, this term in the big bracket will always be positive, because the square of any number, positive or negative, will always be greater than 0. So because this term will be greater than 0, it has the ability to reach to positive infinity for positive values of a. So this term has a maximum value of positive infinity. However, the minimum value is 0, because out of all positive numbers, 0 is the least positive number. So uh, this expression will always be positive, and the minimum value is 0 at x equal to minus b by 2a. If you put x equal to minus b by 2a, it will be the minimum value of this expression 1. So we will say the quadratic expression y equal to ax square plus bx plus c has reached to a certain minimum point where expression 1 is 0 at x equal to minus b by 2a. So at x equal to minus b by 2a, and from a, and from this equation a, we can say the minimum value of y will be equal to minus d by 4a, because at x equal to minus b by 2a this term will become 0 and we are left with minus d by 4a, and this is the minimum value of that this polynomial where a is greater than equal to 0. So this is the point where the value of the quadratic expression starts to either increase or decrease, and we see a uniform symmetric u-shaped parabola and its vertex at minus b by 2a comma minus d by 4a. So this is the x coordinate of the vertex, this is the y coordinate of the vertex of the parabola. However, if a is smaller than 0 here, in expression a, look at this expression a, if a is smaller than 0, this term in the big bracket is always positive, so this expression 1 will always be negative, so much so that it can contain values up to negative infinity. For very larger values of x, because a is negative, it will become a very larger value, negative infinity. So we cannot calculate the minimum value of the expression, because we do not know which value is minimum, but we can certainly tell that what will be the maximum value of this polynomial, this expression y equal to a. So this polynomial will have the maximum value minus d by 4a when at x equal to minus b by 2a. If x equal to minus b by 2a, expression 1 becomes 0 and we are left with y equal to minus d by 4a. When a is smaller than 0, this value of y becomes the maximum value of the polynomial, which is minus d by 4a at x equal to minus b by 2a. So this is how we understood this thing, the maximum and minimum value, through algebra. Now if we see the geometry of this algebra, we will see that this is the parabola y equal to ax square plus bx plus c, or function of x. This is the axis of symmetry. Axis of symmetry is the dotted line, and these are the two roots, alpha and beta, and these are different points on the parabola. Certainly we can see that because the parabola opens upward, so it has the ability to reach up to minus infinity. The y value has the ability to reach up to minus infinity for different values of x, and then it comes nearer and nearer to the x-axis and reaches to a minimum value. The y value here is minus d by 4a, which is the minimum value of this polynomial. And when these are the polynomials when the value of a is greater than 0 in this polynomial. If a is positive, then it will open upward and it will have a minimum value of y minimum is minus d by 4a at x equal to minus b by 2a. Similarly, a will be minimum, y will be minimum when a is smaller than 0 and the maximum value is minus d by 4a. Thanks for watching.